Hello everyone, so today we're just going to take a quick look at the divisibility rules. So this is just preparation for the A-Level Further Maths Further Pure 2 exam that's coming up. I believe it's tomorrow, so this is just quick exam prep to help everyone, but it'll be useful for in the future if anyone wants to do revision for this, or if you just generally want to know the divisibility rules. Here they are. So for the exam, you need to know divisibility by 9, 3, 11, 4 and 6. So obviously 2, it has to be an even number. 5, it ends in 5, or 10 for example. So them ones you just need to understand anyway. But these ones all have some special rules connected to them. So for example, let's start with this one, question 1A. So I'll put A. Oops, what colour are we in? There we go, so let's go to white. So A. So we want to know whether 2,502 is divisible by 9. So the way to do divisibility by 9, you might already know this, might not, but let's go for it. So 2,502. The way to work this out is you have to add up the individual digits. So we've got 2,502, so that's 2 plus 5 plus 0, so that's just going to be 2 plus 5 plus 2. So 2 plus 5 plus 0 plus 2. So 2 plus 5 is 7, plus 0 is 7, plus 2 gives me 9. 9 divides 9, so therefore 2,502 is divisible by 9. So the trick for divisibility by 9 is you add up the individual digits. If they add up to a number that's divisible by 9, it's divisible by 9. So therefore 9 does divide 2,502. And remember guys, for divisibility and number theory, this is the notation we use. So this just means 9 divides 2,502. This is the notation we use. Divisibility by 3. So divisibility by 3 is very similar to 9. All we're going to do is look at the digits again, add them up. If the number that when we get the result of adding them all up, the sum, if that's divisible by 3, then the number itself is divisible by 3. So let's do that. So 5 plus 9 plus 3 plus 1. So what does that give me? So 5 plus 9 is 14, plus 3 is 17, plus 1, that's 18. Clearly 18 is divisible by 3, we'd get 6. So therefore, 3 does divide 5,931. And there we go. So that's B done. So that's divisibility by 9, divisibility by 3. So they're very similar. Divisibility by 11. So this one can catch a lot of people out. There's a bit of a different rule. The way to do divisibility by 11 is you add the numbers again, but you alternate. So for example, we've got 101,795. So we start with the 1, that's going to be positive, and then we take 0 away, but that's just going to be 1 again. Then we add 1, then we take 7, then we add 9, then we take 5. So let's do that. See what we get. That's going to give me 1. So minus 0, so that's just going to be I won't even bother writing it, plus 1. And then I'm going to minus 7, plus 9, I'm going to minus 5. And what does this give me? Well, this gives me minus 1. And clearly, minus 1 doesn't divide 11. So, therefore, this is not divisible by 11. This number here, 101,795, is not divisible by 11 because the result here, minus 1, does not divide 11. If it would come out as 22, for example, let's just say hypothetically, then yes, it would be divisible by 11. But because it's minus 1 and minus 1 does not divide 11, the actual number itself is not divisible by 11. So therefore, we can write 11, sorry, does not divide. So for does not divide, it's just this little bit of notation. I just put a line through it. 101,795. So we're halfway through. So let's do D. So D. So we're doing divisibility by 4. Divisibility by 4 is actually quite a quick, nice one. All you do for divisibility by 4 is check the last 2 digits of the number. So for this number here, my last 2 digits are 6 and 0. If them last two digits even, I can't speak anymore, are divisible by 4, then your number is divisible by 4. So 60 is clearly divisible by 4. 4 divides 60. So this implies 4 divides this number we've got here. So 2, 0, 0, 5, 6, 0. And that's divisible by 4, so it's quite a quick one. Just check the last two digits. If they're divisible by 4, then your number is divisible by 4 as well. E, what have we got for E? Divisibility by 6. So divisibility by 6 has two parts to it. The number has to be divisible by 2, so it has to be an even number basically. In this case it is. It ends in an even number, so it's clearly even. And it has to be divisible by 3 as well. Now you've got to understand divisibility by 3, so that's what we did for part B, so this one here. So it's clearly divisible by 2, so, you know, I'll just put divisible by 2 like that. We've got to check for divisibility by 3 now. So, like we did here, we're going to add up the individual digits, check if they're divisible by 3. So, 5 plus 1 plus 7 plus 9 plus 2. Let's do that. My mouse is being really dodgy today. Plus 9 plus 2. Let's add these up. So that's going to give me 24. And 24, yep, it's divisible by 3. So this implies 3 divides 24. Because you can times 3 by 8 to give you 24. So therefore, this number here, so 6 does divide 51,792. Perfect. And there we go, guys. Nice and easy. And then finally, F. 132, 1,326,094. So we've got to check whether that's divisible by 11. So remember divisibility by 11, we alternate the digits. So we start positive, subtract. So let's do that. So what's that going to be? It's going to be 1 minus 3 plus 2 minus 6 plus 9. Oh, sorry, ignore me. That's a minus 9. Whoops. So yeah, minus 9 because that's a 0 there. I'm getting carried away here, the 0. And then plus 4. So don't get carried away like that. Make sure you're very attentive in your exam. So plus 4. And what do we get when we, calculate this? So that's going to be minus 11. So this gives me minus 11, and clearly minus 11 does divide 11, right? So this implies divides 11. So therefore, our number, whoops, ignore that. 11 does divide 132. Make sure yours don't look this scruffy in your exam as well, guys. I'm quite a messy worker. 6094. And there we have it, guys. So them are your divisibility rules that you need to know for your exam. But best of luck, guys. I'm sure you'll all do fine. But let me know how you're feeling, and best of luck.